Hello, hello, hello. Oh wait, I didn't verify that it's the correct microphone, but I think it is. It is. Cool. Alright, all good. Hello, Penguin Operator. Welcome, welcome. Yeah, sorry for not streaming yesterday and Wednesday. Kinda was busy with other things. Real life and stuff like that. Happens from time to time. But yeah, we're here today. We probably won't be here tomorrow, unfortunately, but that's another story. We will be probably back on Sunday. Well, yeah, I don't have any plans on Sunday, so should be pretty locked in that should work. Let's quickly change that here. Instead of using the array accesses, which are slower. Well, probably not really slower, but let's do that. Okay, so what did I do? I worked a little bit off stream today. On the shader generator, but we are not really that far yet. But where is it? Here I have, I think, my shader. Test shader. No, test material, sorry. And this is the output, and if I copy that to a slang shader, I think I did already here, yeah. Then we have basically already almost a valid shader. The only missing part are the push constants, which we can easily do. And all of that is done in a way better and cleaner way, I think, now, in terms of how a shader is built. Because before, everything was a little bit fragile, and I hope that this iteration of the shader generator is a little bit more stable. Because technically we should be able to do a very similar setup for the vertex and fragment stage. So what we do is we build our structs in here. Well, yeah, that is commented code that will die. Let's go all the way to the bottom. So what we do is we add inputs and outputs to stages. And then with that we can generate the vertex, well, the input and output structs, and those are getting input into the actual body of the function. And last but not least, we as well have a post stage where we could do some additional body things. Although we probably, well, I'm not sure if I will remove it, but we will definitely not keep it. But that's a detail. Let's first try to get a valid, because currently I only have a vertex stage. Let's see if we can get the fragment stage as well, and once that is done, we will probably need a little bit of cleanup. Probably. I don't think this is valid. I do think a fragment stage without input is valid, right? So that would work. Question is, should we? Let's actually take that. Okay. That doesn't work, unfortunate. Well, let's take that then. Delete. Generate vertex stage. And let's do yeah, here probably. Let's do a string. Const shader shader generation context. It's going okay. Except for having pain in my lower back because I'm stupid. Besides that, everything is great. And don't ask why. It was the most stupid thing ever. What? Shader stage. Still what? Generate vertex stage actually. Const. Yeah, I did a little bit off stream, not a lot. Just a little shader generator work today. This afternoon. That's the word I was looking for. Oh yeah, I have lower back pain. Yeah. Well, let's say I tried to get into bed and I failed miserably. What can I say? Let's not talk about that. I guess I'm getting old. What can I say? Suddenly I was lying next to the bed instead of in the bed. Which was not very pleasant. Do we... Now let's do a void here, but give it the string, because I think in the end I will probably do something very similar to what we do in C#, where we have a code generator to do like nicer layouting. Just being like, it was dark in the room because my fiance was already sleeping, and I tried to be lazy and go into the bed from like the end of the bed, right? Not from the side, but from the end of the bed. And I did that, and I was on the bed, and then I was trying to get something from the, what is it called? Like the thing on the side of the bed.
What if?
What the hell? Holy shit. Marmalade, thank you. Holy. Wow, I'm not even sure what to say, but wow, thank you. But never feel pressure to do that. Damn. Really, I'm kind of speechless now. Because that never happened. Really, really thank you. Again, I'm not doing this here for money, but I really appreciate it. God damn it. That's insane. And the text-to-speech worked as well, somewhat, I think. Where can I see? Huh. I don't see the message anywhere. I would need to look it up, probably. That's edgy. Exactly, yeah. For supporting OSS. Yeah, thank you really much. Thank you very much, not thank you really much. See, I can't even talk anymore because yeah, that never happened, and I'm not sure how to say thank you except for repeating myself all the time. Oh yeah, we moved that code there for generate vertex stage. That should be fine. I think we want to as well, just to be sure. Stage is vertex stage. We should not card it with anything else. And I don't think I need a message for that. It's quite obvious what that would be if it asserts here. And then we have the input output here, that's fine. I do think I probably want to create a generate vertex stage. Oh yeah, and then here, give the code with it. I hope I can repay that soon with an engine that's actually working and usable so that you can build something if that's of interest to you. If not, then that's fine as well, but that would be at least a plan. Okay, so that... Oh, well, it's should be const actually. No, it is const. What's the pro? Oh yeah, it's void. Okay. And then we go all the way up, a little bit down, do another function here. Probably do a void generate imp stage input. Really, thank you. That means as well a lot. Because I'm trying to do it like how you would structure a proper engine. Mostly because I'm a little bit of, well, perfectionist is maybe a little bit too harsh because there is code that I'm not too happy with. But I try to make it in a way that it's reusable and somewhat decent. Well, that is actually unfortunate. I think I need to copy paste actually. I don't think I can really make that. I don't think I can make that very generic because it's very stage specific how the input and output struck, like what's allowed and what's not allowed and stuff like that. I don't think I guess we could do a filter. That could work. I mean, let's try. Let's try. So let's go back to generate vertex stage. And so what do I need actually? I want to generate the vertex output and the vertex input. Plus I want to fill those two. So that I have in the end maybe we actually... Okay, let's try. So we do generate stage input. We give it probably the stage context inputs. And let's get out string input parameter input entry point parameter. Let's do it like that. And then we give it the out code as well, because we want to do that, plus a filter function. And the filter function is basically just that. So basically we get an const shader variable input, and we say return input semantic as shader semantic none. That basically that gives us all the parameters that we can put into the struct, and if it returns false, it's a built-in type like the vertex ID, which we cannot put into the struct. That would be the idea. So let's go where we can probably take a couple of things here then, like that. Go there, put that here. Const shader generator stage context. RHI shader generator. Hello. Is that private or what? Oh, it is. Why would that be the case? Okay, I'm clearly... What? Oh, now it works, whatever. Just had to save a couple of times. Stage context. Well, actually, we probably don't. Wait, actually, we don't need that because we get the inputs, right? We don't need that. Change inside that. Get a dynamic array of shader variables. That's what we got. Const inputs. And then we had the string out code, right? And then what we had is a filter function. So basically template type name t. Is invocable. Should be like that, right? That should be good enough, hopefully. T filter function. And then here, well, actually T invocable R, right? And we want a bool as a return type. Is that the return type? Probably, right? Let's hope. Let's hope it is. What am I doing wrong here? Thank you, Ryan2104, for the follow. What am I doing wrong here? Am I not using that already somewhere? Do I need to do invocable maybe? No. Oh, okay. What about... is it invocable RV? It's that, yeah. That's for the value, right? And that returns true or false. Is that it? Yeah, probably. Inputs. And then that should give us those. And then if we have members, we output that. If we don't have anything, it's probably an error, but yeah, I'm not sure. Let's do it like that for now. But we do as well UN32T saw member count maybe. Is instruct members size const, and probably if member count is greater than 1, then we do it like that. Else we just put the thing directly in. Else we just do generate shader. Oh well, actually we can just, yeah, we can just generate the shader wherever. Let me think, because we're doing it 2 times then. So maybe we just do that. Then we need to do a new space here for sure. And then here the glue would be this. Pretty sure. And then this one would just be instruct members. Like at 0 basically. That would actually work. Probably. And the emphasis is on probably works. And then we do the same for output. Generate stage output. Where we get the outputs. We as well have a filter here. Oops, output, probably. That is outstruct members. We don't need that. Yeah, we don't need that. And then in that case, wait, actually generate vertex. I think the the output is easier. Yeah. I think the output is just that always. Stage output, which is probably stage context outputs. And then outcode. Code. Yeah, outcode. And then probably that's not needed. Outputs, outcode, we don't need a filter function, I think. That would be that. It was pretty good. I think he will still run into issues because he has zero guards against other compute shaders overriding things, especially in his collision thing. Because the enemies are probably fine, because each enemy just writes into its own buffer address, but I think the grid, as there is like enemies putting information into the same grid cell, I think that's why he has these weird bugs of enemies like being stuck or not walking or whatever. And as well, there's still some issue with the correlation. It seems like some enemies sometimes walk through trees, but I'm not sure if the trees are just visual in this area or there is collision there. But otherwise it's pretty impressive. But I mean, I kinda expected that. I mean, the GP, like the compute buffer, compute shaders can do a lot. So I'm not surprised that they can like do 2 million. It's on the GPU, everything. He does the collision and the grid update on the CPU, on the GPU, with another compute shader, I think. And yeah, that doesn't really work because he has a maximum amount of 16, I think, per cell. So 16 enemies always want to write into those cells, but the 17th could write into that cell as well because there's no lock or anything in between. No atomics, nothing. But I mean, maybe it works because as long as it doesn't get lost. No, I mean, no, it definitely doesn't work because the decrement would go to 0 even though there is enemies probably in those tiles. So I doubt it's working like how he thinks it should work. But yeah, no, but still, I mean, kinda obvious that it works, very efficient. The interesting part will be once he has to do like real gameplay, because now they are just moving, right? Basically, it's now a particle system. I think he will run into it will be more complicated once he wants to do actual interaction with the enemies, because he plans to have the player on the CPU side, and then I think he might run into weird delays where something takes longer that he would want, like a couple of frames and stuff like that. But yeah, maybe not. I mean, it can work for sure, but I think he underestimates how difficult it is to get it right, I think, on the GPU, because debugging is just way more painful. Yeah, this, I need this so that it's escaped. Okay. And I think I want to do the same here. Or do we give it the shader stage maybe? Let's do them here as well as the shader stage. And then let's do here stage output. And we do here stage input. The readback latency latencycy I think will be painful, to be honest, because it can be 2-3 frames, and I don't think 2-3 frames. I mean, in that kind of game that he does, it might be okay, right? Because it's not a shooter or anything. But usually the readback is like delayed by how many frames you do in flight. So yeah. And he already, like, when he did, I mean, maybe he doesn't want to do that. I think it's unreasonable to do a game like that, but when he did like his million enemies or something like that, the readback was already very expensive. And to be honest, I'm not sure if it's worth it, because the thing that he now did is he did the compute shader, and then he still had frame issues, right? And now he fixed his rendering to do instance rendering basically, and now it runs. But I'm wondering, wouldn't it have run on the CPU with a little bit more threads just fine as well with instance rendering, because probably the rendering was the bottleneck that he had before when he does like 40,000 draw calls for enemies. But that's a little bit of what if, and I mean, probably he can get more enemies on the CPU for sure. It's just a complexity, I think, of actually doing gameplay on the GPU with debugging and everything. Where were we? Oh yeah, generate stage output. I think that should be fine. Oh yeah, and we need the stage context stage. And here as well. Why would you not be happy with that, huh? Oh, we're not outputting anything. Ah, because we need to change that, return that, and then return that here. We don't insert here. Oh, but that's a problem, right? Wait. Oh no, wait. Yeah, we do that. And then we do the join down there, and we return that. Return join of entry point input parameters with a space and a comma in between. And then this is a string. Yeah, I mean, it's impressive and it's nice to look at, but yeah, in the end, what he currently has is just a fancy looking particle simulator, right? There is no gameplay behind it, and that's still good, but it's nothing new. It's a particle simulator for now. Why would you? Huh? Shader stage? Oh, wait. Oh, yes, we need that and const shader variable, probably, right? Is that it? Wait, it's first return type, then function, then arguments? It's bool, t. It's like that? Oh yeah, it is like that, okay. Yeah, and I mean, again, he probably can do way more enemies with that approach. The question is just, does it make sense, right? But yeah. Input entry point parameters. Well, entry point parameters. Okay, so that should be fine. And then we do that. And probably here. And we always do that output, I guess. That should be fine. Let's get rid of that. We don't need that anymore. And then let's go here. Let's copy that. Let's put that here. Well, in that case, we probably even can do that. No, we can't because we want a generate fragment stage, yeah? And it might be very similar. So maybe we reuse stuff? So the fragment stage, it needs an output as well, so that one is for sure the same. It doesn't necessarily need an input. So that is valid. So let's actually try generate graphics stage. Let's do that. And let's call it vertex or fragment. And what we do is stage is either vertex or stage is the fragment stage. Fragment. Graphics. Well, actually, let's do that. Vertex plus stage, and we give it the stage context stage. And then, yeah, we need the filter then here. Okay, well, let's move that then. I think I want to actually then not have that here. Because we don't really need that here. We go here, where is it? Ah, it's called generate graphics stage, yeah. We take that, well, we take it with the command. Take that out, go all the way up, a little bit down, in here. Yeah. And we basically take again the filter function. Just so that we have a thing here. Input filter function. We probably should comment what that actually does. Why is that? Ah. Yeah, okay, in that case now we need to make it public. Because we cannot actually anymore access it otherwise. And then we have this, we generate that. This would be the input filter function. Then we generate the output and then we do that rest afterwards. Oops. Generate graphics stage. And we do that and then we pay. That's not what I wanted. That's what I wanted. Perfect. And then we take that, put that here, and that filter function is... So what do we not want in... Yeah, in the input we only want position and depth, I think. Is the only allowed one. Position? No, depth is... Wait, in the input it's only position that's allowed, right? No. It's position and none, I think. Or none. I think it's one of those is allowed, right? The other ones are not allowed. Hello, Pushleskov. Sorry for butchering that. Oh, welcome, welcome. Welcome to the stream. Let's get rid of that comment. Go here. We need to adjust this here, so this one is format. Well, actually, we can probably do that in place. By going here, stage. Where? Stage context stage. Main. Oh, but that would be uppercase then. That's a little bit annoying, to be honest. Then let's not do that. Let's still do that. Format that. Stage context stage. We need to save that as a string, unfortunately. And then entry point name at 0. I think that works. Does that not work? Do I not have that function? I thought I have that. I mean, I guess what we can do as well is that to lower. and then we add the main afterwards. Here. Entry point prefix maybe. Cool. Actually, let's do it slightly different. Do I need to do it slightly different? Wait, maybe I don't. Or no, yeah, we don't. Here we just do the same thing, just with output. And then that will be here, that. So that would be that, I think. That should work. I think we probably want to get the string output type from here more probably. Yeah, we do. I'm not generating it currently anymore, but we do have that, yes. Let me think, because if it's only one thing, we don't need an outstruct. So basically, if our outputs... but then we don't call that, maybe. Maybe it's as easy as that. If our stage context output size outputs count. Yeah, let's do that. And then we cast that, of course, static, well, numeric cast. And then if our outputs count is exactly 1, and we do it slightly different as we do this part here. If it's just 1, what we will do is, or not that basically, or we need to do it as a string again, otherwise we override it. That's an unfortunate side effect of how stupid my format currently works. I need to look at that in the future. But it's fine for now. So we get rid of that. In this case, output type is just to slang type or something. A slang. Oh my god, what is it? Not that one. Other shader. This one. Output type. And this is output, well, stage context outputs first. That would be the type. Oh, maybe the rest is fine. Because we just still generate the output thing as is, and we just return it then at the end. I think that's fine. Where this needs to be as well Where is my shader stage lower? String lower. Well, no, let's actually no, let's keep it because it actually works out, even though it's maybe not ideal. String stage string lowercase stage string, and this where okay, lowercase stage string, and then this is too lower. Good, because we need it here. Maybe. Do we want to take a bet that this doesn't work? No, it's a custom. It's the it's a custom wrapper around STD format. The 20. Did it come in 20 or in 23? But I mean, it's the guy who wrote FMT who wrote the standard library implementation, basically. So it's kind of the same thing. At least I think to remember that it was the same guy, but maybe I'm misremembering. Stage requires out. Oh, is my fragment stage probably causing issues, right? Yeah. But why is that? Do I not create an output there? Generate. Oh yeah, we don't. Add output. You add color output here. Shader data type float 4. Shader semantic target. What is that? What is that? Hey, Sarah Shaw. Hello, welcome everyone. We don't really have a lot of awesome things today, but nonetheless, welcome everyone. Slang is going great. I mean, you will not see a lot of difference, but I can show it in a second. Give me just one quick test of my shader generator, and then I can show something. So this should be again then in test material. Is that a valid slang? It looks fine, but let's paste that into the slang version of this shader. Test material slang. Yeah, that looks. Yeah, okay, there is a semicolon missing here. That's totally fine. Otherwise, it looks decent. So if we add that missing semicolon here, which I exactly know where it comes from, we are just missing the push constant. Otherwise, it looks. Well, okay, the fragment stage doesn't have an input. Oh yeah, because I'm not doing that yet. Makes sense. And then, yeah, slang is fine. Let's hope I didn't break my scene view. No, I didn't. So this is already all running in slang again. And I hope, yeah, the terrain works. We have displacement mapping on the terrain, so you can see little bumps here. It's best seen on the sphere, because when we look up, you can see the bumps here. So we have like displacement map on the terrain. The terrain is still a perfect sphere, but it's like small details, right? That the player will not collide with, but it's a small detail. it adds. Yes, it's still an SDF function with like we sample the SDF, and then once we have a hit, we displace the hit position based on a height map of the texture to give it like a little bit more bumps. That's the simplified version. It's a little bit more complicated than that, but that's the simplified version. We still need MIPS and stuff like that. We don't have that yet. And yeah, I'm not sure if you saw, but we technically have physics as well. But I think you saw that already, but maybe not. So if I give myself here a capture, and then we give ourselves a character body, we should be somewhere here, yeah, and then we can theory, oh yeah, we need to do virtual, and then we can move. And this is on the ground. It would fall if it's not on the ground, right? It will fall through the ground. I mean, I can show that with a box, I guess. Or is it here? And then let's put a box high in the sky. Give it a box shape, 50, 50, 50. Rigid body, and then it will come down slowly. Bonk. Yeah, it's jolt with a custom collider written for the terrain to sample the SDF on the CPU side. If that is good enough and performant enough, we will find out as soon as I will add a couple more entities. I want to finish off the conversion to slang, and then I want to actually do a somewhat stress test of the terrain, if that even scales. If it doesn't, we need to go back to generating a mesh probably for the physics. There is a couple of ways how you could model that in like with SDFs. Either so the long-term plan is that I have a importer that could import your mesh and create an SDF out of it. That is very similar to the approach that PhysX does as well for its GPU SDF collision. That would be one way, though I would not recommend that. This SDF thing is mostly aimed at terrain, so you will get a terrain panel to like the usual height map stuff like raise, lower and stuff like that. You will get that. And as well, the base terrain is intended to, let me restart. Well, actually, yeah, that might actually not work. Well, let's see. The base terrain is intended to be controlled by as well a volumetric graph. I do hope I have one. To be honest, I'm not sure if I have one. Oops. Data. Oh, I do. Let's see if that still opens. Yeah, okay. So you have a volume out node that gets automatically created for you, and then you basically just say what you like. You get a voxel position in that's a 3D word position, and then you return more or less the height. It's at the height and the normal at the position. It's what an ISO value is basically. The ISO value is the distance to the surface. Where it's 0, there is terrain. Minus values are below the terrain. Positive values are above the terrain. And then a gradient, which is basically the change of the function, but it boils down simplified terms to the normal. And this is a noise function. But you could do a plane, then put a sphere on top. I think we have that here as well. I think this one. Oh no, this is just a sphere, right? And then you would go. Well, I don't think it works now because yeah, that shader generator is not done yet. That still converts to GLSR. So we need to do that. But yeah, that's the long story or something like that, or maybe not so long, I don't know. How do I so we had the missing semicolon. That is a little more like, it's a little sad that happens. I know why it happens. But how would I want to prevent that? Probably one way would be I could add the semicolon here. I guess what we could do is we can get the member count const bool oh wait, that doesn't work. No, we need to have it here, never mind. And then the only question is, I guess the last one we can just add by hand. Probably. No, this would go away. I think that should do it. Oh yeah, and then we need the push constant. So first of all, we should add the push constants again. So we should do this. Push constants and place back. What are you? Shader variables. Okay. So basically we want to do that with a name, a type, and we don't support an offset anymore, I would say. For now we don't support an offset. Well, let's do 0. Well, let's ignore it. Never mind. Maybe unused for now. Hey, it's going great. How is it going on your engine? This. Oh, and then play spec doesn't want the struct. It's going pretty good. Can't lie. We are still in the process of porting everything to Slang, even though the shaders itself are mostly done. Now it's the node graph 2 shader generator, but I already improved it quite a lot. Okay, so we do that and then generate shader stage, not that one. I guess we could do generate push constants. Yeah, that should do it, and then this is just code. And does that work? We do this. This one is actually simpler. This one is probably generate shader variable. Plus equals that, plus that. And then we have textures optionally with it. And then we close it. Yeah, fair. That should do it. Let's see. Oh, that sucks, yeah. I've been there as well. It will pass, don't worry. It's probably like a lot of small things that you think about and then you cannot really focus on the one thing that you want to do. But it will pass. Test material. Let's take that, yank that, go to test material slang. I mean, we could already change the output. Oh, okay, UVec3 is not valid. Oh, it's not, yeah, it's not UVec3, it's uint3, right? It's this. And uint2. Yeah, okay, that makes sense. And then Okay, yeah, we don't have that in the push constant, so that's fine. That's just me not outputting it. Alright. I think we are mostly done. Okay. So let's try to fix the last remaining issues, which was... Oh yeah, the UVec. I think that's in the header. Yeah. So that's a U in 2, U in 3, and U in 4. Although I might... We will see. I might do custom types. Well, custom names for types. But was that the issue? Well, probably, right? Because we do this and then we go here. Well, not here. Go to push constant exactly, and then this one probably went internal too. Okay, generate push constants. Oh wait, no. Oh yeah, it goes here, type as string, and this one is the header, right? Yeah. Yeah, okay, and this did it wrong, yeah. Okay. Let's see, I wanted to look at something. Slang. Type defs. Does it have something like using? Does it have something like using or type def? Slang type alias. It has using of namespaces. But does it have using of... Well, let's try it, I guess. Let's go to our ImGUI shader and just try it. Let's say using vector 3u32 is an vector uint 32t3. I think that's how. Well, okay, I guess that doesn't work. Sad. Because that works, but it doesn't work that I do a name for it. Sadness. That would have been nice. But I guess you can't have everything, even in the wonderful land of slang. Well, okay. Then I guess we just do it the good old way. So, I mean, those can stay. Yeah, then we have this for the special types. And we probably do the other types down the line. And we don't need them now. But yeah, we need to do them as separate vector. instead of having a nice name for it, but it's fine, I guess. Oh yeah, so I wanted to fix the PBR generator, I guess. The question is, do we even... Because I don't think I need any of that. I think what I can do is shader stage, vertex. We can do that, and then we can do this beautiful thing. And then this basically, well, yeah, okay, I mean, I guess we can leave that in for now. Even though that's kind of... Why do we even then need to... No, but then leave it, I guess. Then we leave it. I guess it's fine. Because then we have the stage already in there. And then technically we... Yeah, we don't need to put an input there, right? Because we copy the input over. That would be the idea. So we basically have to do that here. If we find our output stage, we find the fragment stage, sorry, and in here, if our fragment stage input is empty, then we just copy over fragment stage inputs is vertex stage outputs. Simple as that. And that should give us now a perfectly valid shader, hopefully. Well, we still don't have the push constants for the lights, but I will deal with that. One at a time. Yeah, I do think so too. I think that's the reason why. Because it allows you as well to have local, like a color format in the local one, right? In the local folder that like you can use as well and import. Hey, Footlong Ice Seeker, welcome. Let's save that. And let's see if the shader is correct. Hey, Santos, welcome. We are porting on my shader generator to slang test material, and I think we are close to having it done. The formatting sucks, but once I put it into a test material slang, paste it in, save one time, we have formatting. The formatting I will fix later, because those shaders you will never hand edit anyways. But okay, so we have the fragment input, perfect. Why is it vertex input here? That's a bug, okay. Good. That should be fragment input. We'll fix that. And then we need to, yeah, do the push constants. That's the last remaining bit. Okay, so let's go here where we do the fragment stage. Why is the output so stupid? Generate stage output. Input, sorry. the input is the one that's wrong. Ah, here, that's why. I guess we could format it only once, but yeah, let's do it format once. Yeah, let's do it once. String input name. Wait, can I? Yeah, input type name. Format. Well, it's basically this. Well, yeah, let's take it then. I think it makes more sense. Paste that there, remove this, and remove that. So that should do it. Oh yeah, I didn't do the push constant. God damn it. Stop it. Push constants. So for the push constants, the only thing we need to change is actually just give it a u int. Do we have a u in 64 here? No, we don't. Well, we should add that then. U int. Well, u int 64. And then we do a u int 64 here. And then this would be few constants, I think is the name that I went with. Yeah, few constants and probably lighting environment. I have an extra, I will look at that in a second. U in 64. Light environment, I think. And we don't do debug flags. That should be all the push constants I need. And well, actually that's not exactly how I would want to generate it. Okay, I need to... Oh, that would be interesting. Okay, so you said I have one stage too much. Oh yeah, you do. You are right. Actually then, this is a little more complicated. How would I want to do that? Hold on. Probably need a new shader type here. Pointer. And then this is pointer. But then that's not good enough. We as well need a type. Shader variable. How would I want to do that? Probably not semantic. It's ugly, but let's do it like that for now. I have no idea how else I would do it. And then basically, yeah, I think what we change is probably the same thing here. So we do not that. Or we get a shader variable here. Or do we maybe... Actually, let's hold on. Let's do shader push constant, why not? We basically get that plus that. And then let's get rid of that. And then here, shader push constant. Hello. That got this. That's we nuked that one. We do constant dot name, and then we just do a pushback with an std move of the constant. Now we need to change this into a string ID 32, and we are good to go. Why would you? Oh yeah, we didn't change the type probably. Yeah. Shader push constant. Okay. Yeah, then we need to change a couple of things. So this one here, we probably need to change as well. Shader push constant. And then, yeah, we basically reverse it a little bit back. So we again do it manually. Format. We have the type. We have the name, we have a semicolon, and we have a new line. And then this would be variable type. Well, actually, we do that in a separate function and variable.name. Get string and string push constant. Is get push constant type. And we give it the push constant, I guess. Get push constant type string, I guess. Shader push constant const. That one is pretty straightforward. It's if we are constant Type. We're a pointer, we do something custom. Else we just return to, well, that the other function. Generates shader variable, I guess. Well, this one, sorry. And otherwise, is that not it? Oh. Okay. Okay, and then otherwise we do a similar thing. We as well do string view type. Well, do we need that? No, we don't need that actually. We return. Oh, but then we can probably hard. Well, no. Well, we could probably hardcode it. Whatever. Well, return a string view. I mean, sorry. And this is a pointer to the type, to the subtype basically. And then we do here std constant subtype. That should work. Maybe. So the idea then would be that we have a push constant down here. So this one is fine. And then this one would be a few constants, pointer of few constants. How would I make that automatic? We will find out, I guess. I have no idea yet. And then light environment, and it's basically the same thing. Light environment. It doesn't have to be the same thing, it's just here that it is. And I hope that works. That should hopefully give us the correct thing. Or once it builds, I guess. Where is that? Where are we? Graphic types. Ah, that's a format. Okay. U int 8. That's int 8, sorry. Well, I need to rename those. That's vector int 8 t4. That's u int 8t. .32t u int 2, u int 3, and u int 4. Perfect, and then we add the pointer type here. I have no idea what I would put there, because I have no idea how it's used and where it's used. But I cannot give it more because I don't have more information. And uint64 he wants as well. Makes sense. Oops. Oh, caps lock. No, let's do it after the U in 4s. We do the U in 64. I don't know why tab is open. That's the wonders of. Okay. Where is my? Oh yeah, okay. Push, no, shader push constant. Oops. Give me a second, need to send something. Okay. What is the problem? Where do you hate my code except for everywhere? Oh yeah, that makes sense. Case shader data type uint 64. And then case RHI shader data type pointer return PTR, which again that might be a problem, but let's see. I think I need water, but otherwise we will keep going a little bit longer. But I want to get it first to compare the shader again. And then we probably try to build, well, we most likely the easiest shader to build would be a volume shader, so let's try to get that running. And let's see that we can do that today. Oh, why did it go to the second? What the hell did you just do? Why would my screen change? Shader graph, that's what we wanted to do. Data, test, open, save. Okay, I mean it didn't die, that's already a good sign. Test material. Not wrong, test material shader. Well, it didn't fill out the type correctly. Why? Generate push constants. Shouldn't you have done that? Get push constant type string. You are a pointer, and then you should have went in here. Why would you not go in here? That's beyond me. Oh. Wait. Because I'm stupid, that's why. That's why. We didn't take the type then. Well, that was of course not how it was planned. I think that should be better. So we open it again. Save it again. Then we switch test material, go to that, we go to the top, we copy it, test material slang, and save. And we didn't, of we didn't create the push constant, but I think besides that it's fine, right? So we create the push constant struct, and the only thing that's missing is that we need to do push constant, constants. That's the only thing that's missing, right? Oh yeah, and we need okay, we need one more import, which includes math matrix, I think. Or is that not it? Why would that be an error? What is even the error? Does it say anything? No. Expected an expression of type whatever. Input position. But input position is a float 3. And now we give it a float. That sounds perfectly reasonable. Okay, but this one, yeah, this one needs to change as well to constants. View constants. Like that. This one needs to change. Okay, but that's all fine. That's all details. That's like GLSL code that we didn't port yet. This one I'm not quite sure why it complains, but okay. Let's do the push constant correctly. So generate push constants, we do that. And then once we're done with that, we do stage code push constant with a new line. And then push constants with a new line. Okay. That should be that. Oh yeah, and then we need in here we do that, so we need to, well, I guess we could put here math matrix for this matrix multiplication here. And then that is all fine, and then we need to here, that one will change, I'm not sure to what, but that one definitely constants, view constants, camera position, and then this one is input position. That one is for sure, but the rest I'm not too sure about. Which is why I'm saying that this shader is a little bit more complicated to port than the others. Because it actually needs a lot more setup for it to work. But besides that, pretty happy already. So let's do the volume generator and hope that we get a valid slang shader out of that, and then we're more or less good for today. And we do the material shader tomorrow, because I'm not even sure if I have a way to test the material shader currently, because the terrain has a custom material shader now already, and we don't have static mesh. Well, I don't have a static mesh lying around somewhere, but I guess it would be as well not too hard to add one again. Okay, yank that, go to test. Why do I have so many empty lines up there? That's another thing that I'm not too happy about, but I think we can find that out. So I'm still not sure why would you Not like that, so because there is a matrix 4 coming out of that, right? That's a floor x float 4 x4 mat, and then mat. What? Why? Did I not add an overload for that or what? Oh, there is an overload for it. What? I am confused. Oops. Because I'm pretty sure I do that in other places already. Am I not doing the exact same thing? Or would I do that maybe in grid? Oh, that's a vec 3 though. Oh, but it's not a, wait, that's not the matrix. Oh no, it is the matrix. Matrix times vec 3. True, I guess I could do that. Might as well be worth a try. Or did I mistype maybe? No, it's pretty much that. But you can't do that, right? Float 4 x4 with a vector. Am I stupid? What? Let's not save that. Let's restart and see if it just is a... No, it's not. I'm pretty sure I already do that somewhere. I'm not sure if I support reference finding. No, I don't. Where do I do that? I'm pretty sure I already do it somewhere. Maybe in... Oh, wait. Output position is a float 3, that's it, right? That's it. Why was it actually look like, why did it do the arrow here and not here? That's bizarre. Okay, so but why did I do a float 3 here and not a float 4? Should it be a float 3 or should it be a float 4? Ingwe.slang. Should probably be a float 4, right? Because GL record is as well a float 4 and we always get a float 4 in as well. So I think that is a problem. So why is vertex output like that? So I guess at that point then the matrix is fine again, right? Import includes math matrix. Yeah, okay. Good. so it is just the output. And then the question is why shader generator? Why is my output? Probably because I'm stupid, yeah, because I'm stupid. I want to test something because I think there should be an error for that. Yeah, I think we should hit that and it's just not shown. Oops. Yeah, okay. Perfect. I guess we should then just convert it forcefully to. I think we just forcefully convert it to a float 4. But we should probably return an error still. I think we do the same here with the depth. We just forcefully convert it to a float. We should do a proper error handling here. Okay, well, let's actually fix. Let's not do it auto-fixed. Let's actually fix the input here as well. Okay, then 3, 3, that's fine. Yeah, okay. Well, that explains a lot. Okay. So I think we have a shader generator that's somewhat decent. It's definitely better than it was before. It is a little bit more powerful than what it did for GLSR. It's as well a little bit safer in terms of what it outputs. Actually, let's open the shader slang here. Test material. Oh yeah, I wanted to do the look at the why it's a double space, but that's fine. Okay, so that looks good. It doesn't seem that it's complaining about too much. Yeah, this function is not there yet in exactly that form. That's fine. And we don't have a couple of things here, but the lighting changed, so we need to change that function call anyways. Okay. Pretty decent, pretty good. And I'm happy with that. So let's go and try to do a volume. Simplest volume is the sphere. So let's do sphere volume shader graph node. Do we already have everything we need here? Probably. And then we have the volume shader graph. No, volume shader generator. And the only thing we need is this part here, not this. We are not allowed to actually override that, I think. I think I have to remove the virtual on that one. Because that is very, very dangerous if you overload that. Okay, so that is kind of fixed. And this one is the generic. Yeah, perfect. Okay, and then here, what we do is we call this and float 4. Oh, but okay, yeah. Change. If RHI shader stage oh yeah, or then we do that. And mostly because this should be Why would it be fragment here? Oh no, we actually do it in the fragment stage, huh? Oh, but we don't output an entry point, never mind. So it should probably be OR, never mind. And then this probably changes to append code. Ah, I know why. Okay, yeah, okay. Okay. It all dawns to me again a little bit. That would be interesting actually. I'm not sure how to do that. Float 3 for sure. That's a bit of a problem. Because we only allow entry points currently. And this one is unfortunately in the wrong stage. So maybe we do an all here. But it's definitely something that we need to look at. So the problem is that nodes currently output to a specific stage. So what I mean with that is that currently sample texture node, for example, well actually that's not true. They are just appending to whatever the current stage is. They just append to whatever the current stage is. But in the, where is it? Shader graph editor context? Is it there? And then here we call generate. Yeah. And then here, yeah, here we set the stage, which is not ideal in any way. So probably we need to change that. Two strikes again. Well, I wrote that today. And it strikes exactly now. Well, that one is a little bit tricky because the sample node works in multiple stages, right? You can sample in the vertex stage, you can sample in the fragment stage. There's nothing is like telling you can't sample in a compute stage. So the node itself just has to output its content, that's fine. The question is, how do we define which stage we currently try to populate with the nodes? And I'm thinking that for now we will give it from the outside. So basically from here. we will give it the stage. But in reality, it's probably a little different than that. So I think, is it Excalibur or whatever? I think what we want, first of all, make that black so that we are not blind. Where is the fill? Or whatever. No, I want the fill. Please. Send help. Bucket fill. No. Send help. How do I make it dark? Oh, yes. Oh, yes. Good. Okay. Now we can do. So I think what I will do in the end is currently my PBR, like my material shader, has a fixed vertex stage, and the only thing you do is a fragment stage. And that probably stays the same. Oops. But for example, for GPU particles would be the first one that needs multiple things. Probably. Because even the volume graph, that one is as well simple and one thing. But for, well, we could even go with a thing that, let's say the vertex stage. What I would do is I create a new node, which is vertex out. And then we have as well our normal PBR material out, which we already have. And then we have nodes from that like away, and that defines how the vertex stage is done. And then we have nodes from this one out that define how the fragment stage are done. It's in the same UI. We have two root nodes basically. That would be the idea. And then we take this one, and this node says, okay, now we are a vertex stage, and this node says, okay, now we are a fragment stage. And then if I would have a like a random new node like compute out, yeah, then this would set the stage to compute, and you have links to that. And it could as well do that. That should be supported in the graph, so you could do that if you want to. You can reuse nodes, but yeah, that would be the idea. I think that would be that would be fine. And with that we would solve the stage. Because basically the last, exactly the root of the graph, of the end of the graph, determines the stage, because you cannot run multiple stages in like one graph anyways, right? Even for a ray tracing you would have a hit graph, a miss graph, what other are there? It's a hit, miss, and another. There's one more for ray tracing. I forgot it. It's the generation, yeah. Violent, yeah. Okay, you have like those four, and you basically would have 4 graphs in there. Maybe with like sub windows or whatever. I would need to, about the UX we will think later how we would do that, but yeah, basically in the future probably we will do a vertex stage, that you can override the vertex stage if you want to in the graph. By default we take whatever we use for like meshes, right? It will be auto-generated like the PBR shader does right now. So the test material is the default one. So this is the default vertex shader. You can override it if you want. That would be the idea. I think that makes sense. That sounds reasonable and sounds as well extendable. Because with that, with this approach, there's nothing blocking you from doing multiple computes then at that point in like one graph, and you can have different compute stages. With like, as Slang supports multiple entry points. Can you do a sort of import function? Yeah, that would be as well. Yeah, that would be for the actual gameplay graph. I thought about that. I think it makes sense that it's a thing that any graph can use. Basically, you have here a node that basically like it's a graph reference, right? And then it has its output, and you can put that into that, or into any other thing, right? It has like an out parameter, which is maybe a vec4, a float 4, and then you can use it in any of them. Stuff like that, similar to what Unreal allows as well, with like functions in blueprints. If that's what you meant, I'm not sure if I understood you correctly. And it doesn't need to be like a fully functional graph, right? That can be, in theory, inside there. It could just be a create vec3 or something like that. Vec4, let's say. It's in there, then this gets output everywhere. Yeah, I think that makes sense. For now, though. No, we're not. Don't worry. It's sometimes as well really hard. Like you are typing, right, and it's not really easy to bring across a point in text chat sometimes. Or actually, any time it's not really easy in a text-based system to do that. Maybe, you know what? We do it in the generator for now. That is the simplest thing we can do. So volume shader graph generator does that. It creates itself in a public way, of course. Otherwise, we are pretty much done. And then here, oops, we do a volume shader graph, set stage, or let's actually m current stage to shader stage. Do I not have access to that, or what? Do I not have access to the shader stage? I guess not. No, I do. M current stage. Am I not allowed to do that? Is it because it's a member and I'm not allowed to do that? That might be it, right? I need to probably do a forward, like a specific thing here. I need to move those things out. Shader generator, shader stage. Okay, and then this be shader generator. Wait, current stage. Yeah, no, that doesn't work. Yeah, okay. So I was not completely dumb. So that would be that, and then this. Oh wait, that is. I guess we do a get stage. Maybe. Oh, it's a private member. Wait, actually, that's fine. We can do it here already. Just append that at the start and then all is good. All is good. No, we don't even need that. I think because we can do that internally again. So we just add the entry point here, basically. Well, like, let me rephrase that. Actually, we need that to close the scope then again. Or do I need that? Wait, let me think. Wait, I don't even need that. That's all garbage. Can't I? No, okay, I need to do it like that. Probably. Unless I find a different way. And then this would be append code. Just a closing bracket, basically. That would be all. Not ideal. I'm wondering if there is a better way. There should be, right? So I should be able to, in the shader generator, I think, I should be allowed to get the stage. Because then I can do it slightly better. If I'm allowed to do that, then what we are allowed to do is basically get the actually, I might not even need that. I can make it. Why did I make it that stupid actually? Hold on. Yeah, because nobody used it yet and I'm building the system. That's why it's so stupid. Let's not do that. Let's make that. Let's revert that again. And then this gets a mutable thing of the shader stage. And that should do it. And then we go here, we get the stage of that, and we pass that in there. Well, we do a little more than that actually. Hold on, we do a has stage maybe. Do we have that? Okay, no, not yet. Guess we would need that. So if we have the stage, okay, let's call it a little different. So we do an optioner. Yeah, it's, even though we don't really support shader generate or stage. Stage generation context. That's what I wanted. Okay, and then if we have one, we need to do the function for getting that, but if we have one, then we do that, otherwise we do it slightly different. And that's about it. So here, that one is the simple part, we just call that with the stage context optioner dereferenced, and well, actually value and then dereference that pointer. Perfect. Otherwise, we do a shader, well, a stage generation context. We pass it in. And if context has any code, we add it as a thing. M shader stage as add, well, actually pushback, probably around pushback context. And we can probably std move that in, why not? That should do it, and then this one is get stage with the stage. And now we need to implement that. And yeah, that's basically this one here. And we need to slightly change that. So this one we rename to get or create stage. And the other one is an optioner get stage. And then this is get stage. Sure, but I don't think I will be still here, but have a great rest of your evening if I'm not. Yeah. So it would be this and then the reference. The pointer to it. I will put a to do here still. To do change to ref in CPP 26. Because that's what I want. And in CPP 26 you can actually have optioners to references, which is amazing and something I am really looking forward to. Because I think it's an amazing feature. So actually then this is get stage here, because we wanted to do that anyways here. Stage generation context. That is not supported or what? I would need to do a value or what? And then it would be okay. Yeah, I mean, this is actually a slang shader generation, not a GLSL shader generation, if that's what you mean. It was doing GLSL in the past, now it is HLSL. GLSL, sorry. Jesus. Slang. Now I got it. Now I got it. Third try, I got it right. I can show you in a second. We will be able to boot it again. Fragment stage. From a node graph, basically. And then get stage, and then this is fragment stage. Yep, it is pretty much that. I think that should be all. Maybe not. Well, yeah, that makes sense. That is a shader stage generation. Stage. Shader. Stage. Generation context, that. Stage context. And then we do that, we go down, and we replace this here. And stage context, stage. Hello. And then that is pretty much it. Oh wait, I think we wanted a reference to that. Because we want to be able to mute it then. If we need to. I think with that we should be able to do the volume shader now. Yeah, okay, here as well. Shader well, stage, generation context, stage context. And then we go to the CPP. We do need that, yes. And then here, shader, stage, general. Stage context. Are there some good resources? I mean, I really like the official tutorial. Well, is it the official tutorial? I don't know. The Vulkan tutorial is quite nice to get started. It explains it very detailed, I would say. The Kronos one is as well quite nice, yes. And then there is the new one, which I really like because it's modern Vulkan, which is new how to Vulkan. Where is it? So I can post that, but he has a GitHub for it as well. I think this one, but there is a Git for it. Okay, so this one is a nicer page. Yes, let's do that. And then there is a Git for that. And he uses dynamic rendering, buffer device address, descriptor index. Those are really good things because it makes Vulkan so much simpler. Dynamic rendering, you don't need to have render passes anymore. You don't need to have frame buffers anymore. It makes it so much simpler. I have RAII around every Vulkan thing, yeah. I don't know, is it a library or so? I handwritten most of my stuff from scratch because I started most of it when I wanted to learn stuff, so that's why I Vulkan buffer. So I basically have well, everything is wrapped and allocates and deallocates in the constructor. So it's the RAII. I have a lot of Clang format issues here. Not now, not just close it, just pretend it wasn't there. Stage context, stage. And then what we do here is we say stage context code is this format here. With the closing brackets, then we do /n here, /n here, and we put the body code in between, and we do stage context code and get rid of that, and hopefully that works. It's pretty much for free. I wouldn't, like, if you have a performance issue with your destructors and constructors, I would say you probably are doing something wrong. There is, I would say probably it's inlined. If it's not, the overhead of it will be very minimal. And again, if it is an issue, then you're probably doing something else wrong. To be fair, because yeah. Why would... Where did it die now? Why does it not compile? Or does it compile and I just fucked up? Okay, I guess I just fucked up. Okay, so let's see. Shader generator. Shader generator number, test number 3. We save that. We do a data test material here. Replace. And we go to our test material shader. And it's empty. Beautiful. Exactly how I mentioned it. Well, kinda. I mean, that is probably fine. Although, is it fine? Wait, PBR, well, PBR shader generator. Is it fine? Is the other question. Shouldn't you be working? Oh, now it's optional. Yeah, okay, I see. Well. Well, I guess. Wait, where do I push my vertex code actually? Ah, here. And this one gets called from generate shader stage. Ah, but that's optional. That's a bit of a problem. No, but that should be fine. We then do that. We should end up here. And we should push it. Questionable. Oops, wrong. Well, I mean, you're new, so I can as well show what the engine can already do. Quickly, terrain. We have terrain with displacement mapping, but yeah, I need to fix my shader generator. Well, and we have sky and everything. Yeah. And a little bit of physics. Open. Now we have a breakpoint. Perfect. Oh, we are not. I'm stupid. Context. Stage. Is that the first parameter? Yeah, it is. Okay. That cannot work if you're not creating the correct stage. So we open that again. So now we should hopefully get a stage output again. Yeah, so we have everything here again. Ugly formatted. Again, we will do that as a separate pass. It's not really important because it's generated code that you will never touch. But that is actually a almost valid shader. This is wrong. Why did it not? Why did it do that wrong? We get our stage and we get the fragment stage. Oh, because I'm stupid. If the fragment stage doesn't have inputs, we take the fragment stage outputs. No. Probably do vertex stage. Well, we need to see if we have a vertex. Well, if we have one of them, we should have the other one. So I guess we can just assume that one. But yeah, that one is a little bit sus. Exactly. Just write the loop. and it just calls itself. So that should produce, I think, the correct one now. Oops, we want to save, not open. Does it? Yeah, it looks correct, yeah. Okay, fragment input. In theory, we could optimize it and reuse the vertex output struct, but in reality it shouldn't matter, because, yeah. Hello, welcome back. And this makes the code generator a little bit simpler to that each stage just generates its output. I guess in reality the only stages that do that is the vertex and fragment stage anyways, or I'm not too familiar with ray trace shaders if they share stuff between stages. Probably not, because they probably share that with some buffers, if I would have to assume. So maybe we do a special case for fragment and vertex stage in the future to share the struct or not. Was the... Oh yeah, that is as well correct. Perfect. Okay, so let's try the volume shader now. It's probably not going to work right off the bat, but let's see. Create a volume shader. We create... well, we have one actually that we can just save out, I think. Yeah, this one. We open that one. We save that one out. And hope for the best. Test volume. Oh, I already did it as slang? Test volume slang? Nah, that's not correct. What? Oh, it's test volume S here, test volume H here, and it didn't output anything perfect. So the question is, why would you not output anything? Oh, because, yeah, I know why. Shader generator. Generate shader. And then here, after the push constants, we get our OR stage. Global stage. And then we basically do this. And if our global stage has one, if we have one, then what we do is code plus equals global stage. Dot code. That should do it. Do we want to add line breaks around that? Probably one at least. Probably one. That should be fine. Hopefully. Open. Data. This one. Save. Where is my function? What? Well, I mean, almost. Shouldn't you have done a function around that? Volume. Oh, wait. I think I'm again a little stupid. Where is my stage stuff? Yeah, here. If it's or, we are not allowed to skip it anymore. Oh, but can I even do that? Hold on. That's not it, actually. Because count is before that, right? Count is before all, yeah. I guess we could just do count +1. Or we do the... That sucks. I think I will probably change that somehow. I'm not sure how yet. But yeah, so if I is greater than... No, that sucks. I think we might be even better off if we just say... Maybe we are better off if we do this. If we have a global stage, we do that. Else, if we don't have a global stage yet, yeah, we... Okay, well, whatever. I guess we do it like that, and then this is shader stage all. And we call generate with that. If it's not empty, do that. And then here, I need to call this. Because this calls it if we didn't have anything and you want to add it. This calls it the other way around. Is this optimal? By no means. That's not where I wanted to go. Okay. And if we take that, put that into our test volume slang. Save that. And now... I don't think we have the support for that yet, right? I don't think I can do this. This will not work, right? Yeah. Yeah, we could potentially do a hyper function for that snippet with the stage generation. Okay, well, we are not doing that. Probably. Am I even... I'm more impressed that the terrain didn't disappear. The question is why. Volume terrain system. Shouldn't you have done that? Oh, wait, no. Oh yeah, we are not. Well, we run into that, but we are probably not. We're not generating the correct shader. Well, we are generating a shader, but not a full one, because we need to generate this here as well. Okay, we will do that tomorrow. Well, actually tomorrow I can't, because I have a family event, so we will do it on Sunday. But yeah, well, actually I thought I would be already doing that, but maybe not. Volume graph serializer, volume shader graph serializer. Am I not outputting the correct terrain shader? So I mean, this one is definitely wrong, yeah. Oh, what is that? Oh, that's a GLSL shader. Well, that's unfortunate. Okay. But to be honest, I think we can fix that quite quickly, actually. Render terrain slang. Yank that. Go in here. A start here. This one needs to be replaced with test material. No, not test material. Test volume dot slang. And then how does that should actually work, right? And then how did we load that though? It's render terrain shader file name. Ah, render terrain slang. Maybe we need to fix that class for sure, but with that it might already be good enough. No. Hell no to the ChatGPT. Terrain is here. We hit the breakpoint. That is unfortunate. Probably a shader error somewhere. Question is just, what is the issue? That one is fine. Well, I say fine. We have a bunch of validation errors because of the push constants. Okay. Shader compiler. Slang compiler. Let's put a breakpoint here. Let's put a breakpoint here. Oh wait, it's... I think I will know what it is. It's test volume. No, test volume... slang. Isn't this... what is it? Default terrain. It's public export, yeah. Public export. And we need probably this. Well, we only need the sphere, right? We have the sphere here. So I think that might be good enough. So we just need to put the export in front. Maybe. Okay, unfortunately not. Oh, stage? No. Yeah, the shader is invalid, right? Probably. If I had to guess. Yeah. But I mean, why is that even a thing? Render terrain.slang. Is that not it? Is that not what it's called? Project? Oh, it's not. I didn't rename it. Well, that explains a couple of things. But now, right? Now it will work. It works. Perfect. And that is basically how you would do a terrain then. You build your base terrain with a volume graph and then you do fine edits with like brushes. Alright, with that I will call it a day. Yeah, I will be most likely not streaming tomorrow because as I said, I have a family thing and I come back probably at 4 or 5 and then I will be dead because of, yeah, family being exhausting sometimes. As everyone's family, I guess. I mean, I like them, but yeah, it's a lot of people. And yeah, we will be back on Sunday probably again for a long stream. I really enjoyed the last couple of weekends where we did like 4 or 5 hour streams because we get a lot of shit done and it seems like a lot of people tune in as well for those longer streams, so it's a reward as well, rewarding to be able to talk to you people, to you guys. Yeah, thank you everyone for joining as well. Thank you for the raid if you're still here, Sad. And everyone who stayed. Thank you, Marmalade, again for the donation. Really appreciate it. Still speechless about that. And yeah, have a great Saturday and see you on Sunday. Take care, guys. Well, actually, we have a couple of people. Let's raid someone. I always forget that. I'm not used to ratings there. Let's actually raid T.S. Oding. He's kind of fun. Although very opinionated about C++ and C in general. But let's raid him. Take care. See you on Sunday.
Non-leap.